These are the notes for lesson 3-3, day 2. Today we are specifically talking about slope. Slope is the rate of change of a line, and it is a constant number. So just like yesterday, rate of change is still the change in your y values over your change in your x values. It is, once again, a ratio. So we're going to start with deciding, are the following tables linear or not? Are the following tables linear or not? Which means the same thing as, is the rate of change constant? Is it the same ratio every time? Every single time. So, looking at this first example, the x's are 1, 2, 3, 4. The y's are 6, 12, 18, 24. So you have to check every ratio. So this change in y's is 6. This change in x's is 1. So far we have 6 over 1. Check it again. 12 to 18 is 6. 2 to 3, still 1. 18 to 24, also 6. 3 to 4, still 1. So this one is linear. The slope, which is represented by an m, is 6. So let's look at example 2. Our x's are -10, -2, 6, 14. Our y values are 5, 1, -4, -10. So starting at the top, change in y's, in this case, -4, divided by change in x's, in this case, 8. And then you check the next one. How far from 1 to -4? Well, that's 5. -5. How far from -2 to 6? 8. Are our rates of change the same? No. So this one is not linear. The answer is no, because the rates of change are different. So if you were to turn to page 174, you would find problems 3A and 3B. They are currently on the screen for you. Your job still is to decide, are the rates of change consistent? So you have to check every single one. If you happen to catch the one that's wrong, you can call it early, but you still have to make sure they're all the same. So in this first example, we have 4 over 1. And then we have 4 over 1. Looks good so far. 4 over 2. That is not the same as 4 over 1. So 3A is not linear. The answer there is no. So let's look at 3B. -4 to +1 is 5. 12 to 9 is -3. 1 to 6 is 5. 9 to 6 is -3. 6 to 16 is 10, so that's not looking good. But 6 to 0 is -6. And if you reduce that, you get 5 over -3. So all three of these changes are the same. So yes, it is linear, and our slope is -5/3. If you wrote that as 5 over -3, that is the same number. Once you know something is linear, you can just go find the slope. So here are a collection of ordered pairs, x's and y's. If it makes you feel better to write them as a table, you may do so. So we could write this first one as -3, 2, and 5, 5, if that's easier for you to see. So change in y's is 3. Change in x's is 8. So our slope is 3 over 8. You also could have subtracted to find these numbers. You could have gone 2 minus 5 over -3 minus 5. If it makes you feel better to write it that way. Change in is the difference. So for example, number 5, again, a table might make it look better. -3, -4, -2, -8. So this first change from -4 to -8 is a -4. From -3 to -2 is 1. So our change, our rate, our slope is -4 over 1, which is just -4. And again, if you prefer subtracting, you could do -4 minus -8 divided by -3 minus -2 using your proper operations. You would get 4 over -1, which is still -4. So here are 2 more examples, 6 and 7. I would like you to try both of them. They both have interesting answers. So for number 6, when you make up your XY table, or you're subtracting, or whatever it is that you plan on doing, there is no change over here on the Y's. But on the X's, there is a 7. So 0 over 7 is 0. And again, if you wanted to show that with subtracting, you could do 4 minus 4 over -3 minus 4. Always Y's over X's. For example, 7, it's even more odd. -2, -4, -2, 3. On the Y side, we are going up by 7, but on the X side, there is no change. So the slope would be 7 over 0, which cannot happen. This is undefined.